If you found my previous video about deductive arguments begging the question to be philosophically provocative, I can't wait to hear your opinion on the following video in which I will, using the rules of logic, prove that unicorns exist. As you probably guessed if you're into philosophy, I will be using the principle of explosion to prove the existence of unicorns. Now, deductive explosion in classical logic says that if your premises or axioms contain a contradiction, then anything becomes derivable. In other words, P and not P entails Q for any Q. This argument will probably not move those who reject classical logic to begin with, or are paraconsistent logicians, because in paraconsistent logics, contradictions are not explosive. The same is true if you, like dialythicist Graham Priest, reject disjunctive syllogism as a valid rule of inference. To be precise, Priest actually considers disjunctive syllogism to be quasi-valid. Anyway, with those caveats stated, let me now present the formal proof. So on the first line, we'll put our assumption, P and not P, P and not P as our assumption. And to explain the symbols, the P stands for a proposition. It could be any statement, basically. This is the and symbol. This is the tilde. And sometimes it's written like this. So let's see what follows using natural deduction. On line number 2, we will put just a P. And we get the P by applying something called conjunction elimination, sometimes also called simplification. So we will write conjunction elimination. And the conjunction elimination or simplification is justified because of the logical rule stating that if a conjunction is true, each of its conjuncts must also be true. So from A and B, we can infer just A or just B. For example, if I say that sugar is sweet and Ferrari cars are fast, I can infer either of the conjuncts on their own as true. And on the third line, we will apply something called disjunction introduction, also known as addition, and write P or Q. So P or Q. And this symbol is the or symbol. So from line 2, we get disjunction introduction. Introduction. Oh, and I forgot to put which line. So we got this from the first line. So we got the disjunction. So we got the P or Q using disjunction introduction, also called addition, and we wrote P or Q. This is valid because an inclusive disjunction is true as long as one of its disjuncts is true. So because we already established P to be true on line 1, we can conclude that P or any random Q in disjunction with it must also be true. Then on the fourth line, we will again apply conjunction elimination to P and not P, which is in the first line, to obtain not P. So we will write not P from line 1, conjunction elimination. So we did the same as we did on line 2 here, you see. And on the fifth and final line, we put Q. And we get the Q by applying the rule disjunctive syllogism from line 3 and 4. So we will put 3 and 4, disjunctive syllogism. All right. And this is our conclusion then, Q. And disjunctive syllogism basically says that if we have P or Q and we negate P, we can validly obtain Q. So that's what we did here to line 3 and 4 using disjunctive syllogism. So by applying very simple implication rules, we got Q from the contradiction P and not P. And now, by putting the proposition unicorns exist into the variable or sentence letter Q, we have proven the existence of unicorns. But you could actually replace the Q with anything you like, such as Santa existing or the moon being made of cheese. And that's the principle of explosion. From a contradiction, anything follows.